Let's talk about these hello and dead timers and just nail those down because I know these are going to rear their ugly head on your exam one way or the other, and you will definitely be ready for them after this discussion and a lab we're going to do. These timers obviously have very different roles. We're saying hello with one and dead with the other, but they are bound together in one very important way. The hello timer is telling us how often OSPF hello packets are going to be multicast to 224005. We know that on a broadcast segment like the one we're working on right now, then it should be every 10 seconds. The dead timer is how long an OSPF router is going to wait to hear a hello from an existing neighbor before it just says, hey, we're out of here. You know, the adjacency is gone. And right now, let me bring the live equipment back up and we can do, let me raise that up just a bit. Show IP OSPF neighbor. And you can see going across here, we've got a neighbor ID value, that priority, the state. The dead time is what we're really focusing on right now. Because according to this, we have 36 seconds to live. Or at least the adjacency does. So let's see how much longer we have to go now. 31 seconds. And now back up to 38. So what happened there, a hello packet came in and refreshed the dead timer. And so let me ask you this then. At what point should we start worrying if we were watching our broadcast adjacency? We should start worrying about the 30-second mark, really the 29-second mark, right? Because if we go below that, that means we didn't get a hello in the last 11 seconds. We should have, and we're probably in a little bit of trouble. We might just find that out shortly. Let me run another command here for you. OSPF interface. E0, that has our timers right here as well, and now I ran this command in the last video when we didn't have an adjacency, so I want to show this to you now because this has a wealth of information in it, troubleshooting and otherwise. If you were going in and having to make a network map, show IP OSPF interface is going to show you a ton of great stuff. Now if you leave the E0 off the end, I might have mentioned this in a previous video, but in case I didn't, if you leave that off, it's going to give you the OSPF information about all of the interfaces on your router. You may not care, in a lab environment, you have one interface, maybe two, maybe you want to look at the info side to side there. But of course, if you had several of them, you're going to get a ton of information and you might want to tie it down a little bit. Going from top to bottom, let's walk through this command before we do the dead timers. We've got the IP address of the local device. It shows you what area that interface is in. Shows you the process ID we're using, the router ID or RID, the network type, which is broadcast for an Ethernet segment. That cost is 10 for an Ethernet interface. Transmit delay, state DR, that means the local router, the one we're on, is the designated router for that segment. That's always per segment. We're not electing a designated router for the entire OSPF network or for the entire area. It's that one segment they're on. Designated router gives you the ID, of course that's the local one. Then it's going to tell you who the backup designated router is and what their RID is and what their IP address is. Notice the RID and the interface address are the same for our DR and BDR right now. It might not always be the case coming up. Timer intervals are what we're really looking at right now. Hello 10, dead 40. Your dead timer by default is going to be 4 times your hello time. So that means if our hello time is 10 seconds, obviously it's 40 seconds. That's on a broadcast segment. On our NBMA network, where the hellos are every 30 seconds, that means it's 2 minutes before an adjacency is declared dead over our serial links later on. We will see that in action as well. Good information at the bottom tells you how many neighbors you have and who you're adjacent with and even their role, if it's DR or BDR. So a lot of great information here. Now let's step back to the board. I believe I told you everything there about it there is to know. The big thing is that 4 times hello default. That's very important. Now let's go ahead and see that on the live equipment as well. Let me just make sure I turned our debugs off, and I did with show debug. And let's go to our Ethernet interface. And actually, tell you what, I'm going to run some debugs before we do that. I've got the hello debug on for OSPF and the adjacency. And we'll just sit here for a second and watch it because really all we're going to see are hellos coming in. And we know that's going to be every 10 seconds. We don't have any adjacency events going on because we don't have any adjacencies being built or torn down or anything like that. So let's go ahead. Let me show you some extra commands here. These are the IP OSPF interface level commands. We're certainly not going to hit all of them here in this course, but we are going to hit cost, I believe, later, and we'll definitely hit hello now. Very quick data lecture here. Always use iOS help to see. Let me get rid of those debugs, actually. It's getting annoying. Not to mention hypnotic. Always use iOS help when you're looking at a command that is time-based or frankly even unit of data based. Because even just looking at the time commands, some use seconds, some use minutes, some use seconds and minutes, some use minutes and seconds in that order, and then you've got the ones that bring in, days. So you really want to check that out, because in a job interview, if I said, why don't you set the hello timers for OSPF for me to 1 minute? Well, your brain hears that 1 and says, oh, okay, well, IP OSPF hello 1. And it would indeed be hello, because you would be going goodbye. You set it to 1 second instead of 1 minute. And we're not giving away exam points like that either. So whenever you can, production, GNS3, any simulator, get used to using iOS help to take a look at that. It doesn't hurt to memorize this one. I'll certainly admit that it's seconds. And let's go back in and change it to 15. And we're just going to hang out here for a second or two. Well, actually, why don't we run a show command? That dead time's already down to 22 seconds. That doesn't look good. Our adjacency is taking on water. And we're sending up flares. We're down to 10 seconds. And we will just watch that tick down, and then quite frankly, I think it's going to go away. We have 1 second to live, and there it goes. And the full message here, the adjacency, even tells you OSPF, ADJ, CHG, and in this case, the change is that our adjacency went absolutely totally down. The neighbor went down, the dead timer expired. So now I'm going to run those other 2 debugs, and now we'll set it back. But let me run that other command first, the interface command. Let's verify that it did indeed change. And you can see here, it looks at first, it's like, oh, everything's fine. Here's the process ID and the RID and the network type, and everything else is just fine. Well, a couple of clues here. First off, we no longer have a backup designated router on this network. That can happen on certain other network types that we're going to see where you have a DR but no BDR. But the only reason you won't have a BDR on a broadcast segment is that you only have 1 router on it, or you have a problem with an adjacency. We also see at the bottom with the list of neighbor count, adjacent neighbor count, and suppressing hellos doesn't matter. But we also don't see the little list that said, here's who you're adjacent with, because we're not adjacent with anybody anymore. So you could walk into this and look at this and say, okay, what exactly is the issue? And I'm going to run 2 debugs here before we fix it. The first one, debug IP OSPF hello, because the thing is, the hellos are still coming in. We didn't stop them or anything like that, but it's just that they're coming in with mismatched parameters. And this time it's not the mask, because as you can see, the mask is exactly the same. The key is that when we look under dead and hello, those numbers are mismatched. We've got 40 and 60, 10 and 15. So that's not good. I want to run a debug for the adjacency and show you the entire adjacency process when this comes back up. Do not panic or freak, or don't peek either, whatever I was about to say. Don't do any of that stuff, because when you see it, it's like, oh my gosh, are you kidding? I have to learn all that. We are going to delve through it later and pick out some important events, but I just want to warn you, this is probably the most information you're going to see from a debug in this course. IP OSPF, and it's ADJ. People tend to say debug IP OSPF adjacency. I do the same thing, but if you type the entire word adjacency, it's not going to go in. You just have to get used to that. It's ADJ. And I could just put in IP OSPF hello 10, and that would take care of it. But remember, what you can also do is use Control-A to move the cursor to the front of the line and just type the word no. And when you negate that, that means that you have set it back to the default, which should be fine. So let's see what happens when the next hello rolls in here in a few seconds. And holy cow, look at all that stuff. Let's see, we're not quite done yet, but we're close. We're building some LSAs that we talked about earlier. We have a router LSA and a network LSA and a neighbor change event. And I think that is going to be it. Let's wait for one more hello to come in. Yep, and now it's going to go back to its usual self where it just says, here's your hello and the end of hello processing. So we've got all the debugging turned off, and again, no need to panic or fret here. A couple things here we're going to talk about, that DBD, the database descriptor. We've also got our DR/BDR election going on in here, but it hasn't happened yet. And you can see some different packets being sent out and received. There's a link state request packet that we're sending to .2. And this is the key right here. Whenever you're troubleshooting an adjacency or you're watching it, when you reach two-way, you're almost home. That's where the good stuff is happening, because we are actively having a conversation with the router on the other end of the link. We've exchanged router IDs. We've introduced ourselves. Hi, how are you? And we've agreed on these things. And once you have that two-way communication, you are probably all set to go. I have to say probably because there's always an exception somewhere. But that two-way communication means your adjacency is just about done. You can actually see here, here's the exchange done with Ethernet 0. And it's going to have the little OSPF message. Let me move that over. Or not. It's all OSPF stuff. Exchange done, now synchronized. We talked about, at the very end, when it reaches the full state, that's when you're totally synchronized. The databases are the same. They've synced up. Then finally, you do have your DR/BDR election down here at the bottom. It was mentioned at the top, but it wasn't taking place yet. And here it is, and we've elected 172.12.23.3, the DR, 172.12.23.2, the BDR, and everything is just fine. That's exactly what we expected to see. Just a lot of good information in those two debugs, and I have that for you for those of you who did get the study guide. You'll find all this information here. That's what all the screens are, so I'm not skipping over stuff. It's just showing you everything that we just saw on the live equipment as well. So our hello and dead timers match back up, and we are fine. Actually, what I wanted to show you was something here about LSAs and LSUs. And yeah, let's go ahead and hit this now. That sounds kind of like the 2017 Dr. Pepper SEC championship game or whatever, but it's not. LSU might be in it, but LSA won't be. The LSU, the link state update, that's actually the unit that carries the LSAs that I mentioned earlier. So the LSU is basically a carrier for the LSAs. Now those LSAs are first exchanged between OSPF routers when the adjacency reaches that two-way state. That's where we're trying to get. And we saw, of course, that huge output, but we went through that a little bit. We saw the two-way communication begin right there. Once the adjacency reaches that state, it's just about finished, and that's when the routers start exchanging LSAs. And then shortly after that, we saw the rest of this right here. And the adjacency readout, the DBDs that we saw mentioned in the output, they're the database description packets. They're also called database descriptor packets on Cisco's website. I've seen it both ways. And they describe the contents of the sending router's LSDB. Now this doesn't have the full LSA, just the headers. It's basically just saying we're describing this to you, we're just not giving it all to you yet. Well, notice the state init. We didn't spot that in that adjacency, but I'm sure it's there. And this is the initial state of the adjacency, INIT. And when we get that database description / descriptor packet, that takes the adjacency all the way to two-way, which is shown on the next line. And those LSA headers in the database description packet, what they allow the receiving router to do is send a database request for the LSAs that it needs via LS request packets. And we saw those as well, and you can see here, sent LS request packet. It's saying, hey, I saw that descriptor, and I see what you've got. I've already got some of those, but here are the LSAs that I need. And that's when all that stuff starts happening. Everything's just about done, and you can see exchange done. Once the exchange of LSAs is done and the LSDBs on the router are synced up, the adjacency reaches full status, and that is what we want to have happen. Let's review these really quickly. I know this is a longer video, but let's stick with this because I want to put this all in one place. We saw some of this adjacency states, but not all of them. And you'll see some of these in show IP OSPF neighbor as well. So we need to know what's going on in each state. Down is the first OSPF adjacency state. It doesn't mean the interface is physically down. It just means that no hello packet has been received from that router. Now attempt, we're going to see that later. The only place you see this is in an NVMe config like the one we're going to put over our frame relay network. Because attempt means that a unicast hello packet has been sent to the neighbor, but no reply has yet been received. Now init, that's where the good stuff starts. We've gotten a hello from the remote router, but it did not contain our OSPF read. That's what we're really looking for, because that means this hello is not serving as an ACK for any hello packets that we sent out. We're just getting one, because OSPF hellos are always going out and they're always discovering new neighbors. That two-way, that's the we're almost there state, and there are two separate actions actually that can bring an adjacency to two-way. The local router could be in init stage and then get that DDP from the potential neighbor, the database descriptor packet, that DDP that is, and the local router receives a hello with its own RID in there. That's an acknowledgement that the other guy has seen us. It's almost like, you stick your hand out to shake hands with somebody and they recognize who you are. When we get that handshake back, it's like, okay, we see a hello with our RID. That means that we're buddies and we're already at the two-way state. Xstart is where DVD packets continue to be exchanged. It's the exchange start. Get it? Clever, huh? Loading right behind that. The LSAs are requested, they're received, and they're loaded into the LSDB. And as we saw, the adjacencies are in place and databases are synced. We're going to go into LSA types in the very next video. But watch this one, particularly a couple times if you need to, especially because there's a lot going on here at the end. When we had that adjacency come up, and I'll make sure we do a debug adjacency at least one more time with one of the other labs, and we'll see as many of these states as we possibly can. But it really does help you to understand what's going on with OSPF when you understand these states. They're not just to be memorized. Doing that doesn't hurt, knowing what's going on in each one, but it really is great when you can look at that output and say, okay, here are the database descriptor packets, here's Xstart, etc. It really helps it all come together for your OSPF study. Fantastic. Take a breather, and I'll see you on the next video. We'll start with LSA types.